Bismillahirrahmanirrahim. Dear students, this lecture is about Eulers technique, Eulers method to solve ordinary differential equations. This method is very important with respect to every examination point of view. So try to understand each and every step of the methodology for this method. The first one is you will be given a differential equation y prime, which is the function of x and y, usually denoted by this notation. Secondly, you will be given initial guess, initial approximation, y of x naught is equal to y naught, or in the second fashion x naught comma y naught. Third one, you will be given step size h in the question that will be given to you. These three informations will be given to you in questions involving Eulers technique. The most important thing, you need to remember the formula for Eulers method, which is yn plus 1 is equal to yn plus h times yn prime. That is the formula to find the successive approximations. For example, if you need to find y1, you need to replace n by 0 here, so that will be equal to y1 is equal to y naught plus h times y naught prime. This formula can also be written as in this fashion: yn plus 1 is equal to yn plus h times yn prime, which is equal to function of xn and yn. If you look around here, that is y prime is equal to function of x and y. If you replace y by yn and x by xn, so that will be equal to yn prime is equal to function of xn and yn. So that's why yn prime is replaced by function of xn and yn. That is the second notation for Eulers technique. But the first one is more simple to remember: yn plus 1 is equal to yn plus h times yn prime, where n varies from 0, 1, 2, 3 and so on. So let us start an example to understand the idea of Eulers technique. Example is there that solve the differential equation y prime is equal to x plus y subject to initial condition y0 is equal to 1 on the interval 0 comma 0.5. Interval is given to you, and step size h is equal to 0.1 is also given to you. You need to solve this differential equation with the help of Eulers technique. You see that the interval starts from 0 and ends on 0.5. You need to start from 0 and reach 0.5 by taking this step 0.1, that is 0, then 0.1, then 0.2, 0.3, 0.4 and 0.5. So let us start the solution of this example. Y prime is given to you. Y prime is equal to x plus y from here, but y prime is denoted by a function of xy, so that's why I insert function of xy between these two. There is no need to insert this thing, but just to realize that y prime is actually function of x comma y, which is x plus y. If you replace y by yn, so that will become yn prime, and x by xn, so that will become function of x and yn, that is function of x and yn, and this is equal to x is replaced by xn and y is replaced by yn. So that is actually yn prime. Secondly, initial condition is given to you: y of 0 is equal to 1. So y of 0 is equal to 1 means that x naught is equal to 0 and y naught is equal to 1. That is, x naught is equal to 0 and y naught is equal to 1. That is the initial condition. Now just look at this table. If you look at this table, in the first column we have written the values of n, n starts from 0, 1, 2, 3 and so on. And this is xn, because in this formula x is used, you see here x is used and y is used. So the second column is about xn, the values of x highs. You see, when n is equal to 0, so that will become x naught, and x naught is given to you 0. From this interval you see that the first value of x is 0, so x naught is 0. Now if you go towards 0.5 by taking this step, so after 0 there will be 0.1. so that's why x1, when n is equal to 1, so that will become x1 is 0.1, and adding 0.1 successively downstairs, adding h downstairs here. So when n is equal to 2, x2 will be equal to 0 plus 1 0.1 plus 0.1 is 0.2, x3 is 0.3, x4 is 0.4, and last one is x5 is equal to 0.5. that is the last value of this interval. So that's why we reached x5, which is 0.5. that is the end of this column. Now in the third column we have written the values of yn. When n is equal to 0, then y, that will become y naught, and y naught is given to you, that is 1. So y naught is equal to 1. Thirdly, in this column we have written this question which is given to you, this function which is given to you, yn prime is equal to xn plus yn. So that is the fourth column. Remember that there is a fourth column for this question, and whenever you replace n by 0 in this equation, you will get y naught prime is equal to x naught plus y naught. So that is y naught prime is equal to x naught plus y naught, but x naught is 0, so x naught is 0, and y naught is 1, so y naught is 1, so 0 plus 1 is 1. That is the value for y naught prime. Y naught prime is equal to 1. Now the last column contains the formula for Eulers technique, Eulers method. That is the last column. So writing here the Eulers formula, yn plus 1 is equal to yn plus h times yn prime, and because n is equal to 0, so replacing here n is equal to 0, you will get y1 is equal to y naught plus h times y naught plus h times y naught prime. So that is y naught, y1 is equal to y naught, y1 is equal to y naught plus h times y naught prime, that is y1. Now replacing y naught by 1, because y naught is 1 from here, so that is y naught is 1 plus h is given to you 0.1, so replacing h by 0.1, and y naught prime is from this column, y naught prime is equal to 1, so replace y naught prime by 1. So this is the value for y1. Calculating this sum, you will get y1 is equal to 1.1. So this whole row is about n is equal to 0. Now whenever n is equal to 1, that will become x1, and x1 is 0.1 because of step size, adding 0.1 to 0, so that is 0.1, and that will become y1. You have calculated y1 by Eulers technique, y1 is equal to 1.1, so writing y1 is equal to 1.1, and here when n is equal to 1, so that will become y1 prime is equal to x1 plus y1. So y1 prime is equal to x1 plus y1, but x1 is 0.1, that is 0.1, y1 is 1.1. adding these two, we will get y1 prime is equal to 1.2. so that is the value for y1 prime, and whenever you put n is equal to 1 in this Eulers formula, you will get y2 is equal to y1 plus h times y1 prime. So that is y2 is equal to y1 plus h times y1 prime, replacing y1 by 1.1 from here, h by 0.1, y1 prime have been calculated here, which is 1.2. so y1 prime is equal to this thing. Adding these two, we'll get y2 is equal to 1.22. Now in the same manner, whenever n is equal to 2, that will become x2, and x2 is 0.2, and that will become y2. y2 has been calculated here, which is 1.22. so writing y2 here, and whenever n is equal to 2, that will become y2 prime is equal to x2 plus y2. so x2 plus y2, plus y2, y2 prime is equal to x2 plus y2 is equal to 1.42. that is the value for y2 prime, which is 1.42. now replacing n by 2 in this formula, so that will become y3 is equal to y2 plus h times y2 prime. y3 is equal to y2 plus h times y2 prime, but y2 is 1.22 from here, and h is equal to 0.1. y2 prime is equal to 1.42. y2 prime is equal to 1.42. so replacing y2 prime by 1.42, calculating this sum, we'll get y3 is equal to 1.3262. so that is the value for y3. In the same manner, we can calculate from here x3, y3, y3 prime, and y4, and so on and so on. The last column is about x5, so x5 will be 0.5, and y5 have been calculated here. y5 is equal to 1.72102. so that is the last value for y. There is no need to go forward, because we need to calculate the fifth component, the fifth iteration, you may say that. so y5 is equal to 1.72102. that is the last one. Now the question is, how could we use calculator to use Eulers technique? That is very much important, and you need to listen carefully that how could we use calculator when dealing with Eulers.